Hello everybody, welcome to your first geometry lesson for the year, lesson 1-1. Okay, today we're talking points, lines, and planes. Today we're talking about really the building blocks that are going to make up all our geometric figures as we go through the year. Okay, our objective is to understand the basic terms and postulates of geometry. Alright, now why is what we're talking about today important? Well, let's take a look at the piece of architecture I have on the board, the complicated geometric figure here. Now it's a pretty cool looking deal, but if you and I want to have a discussion about it, it would actually be pretty tricky to do without a common language, without a common vocabulary. Okay, wouldn't it be a lot easier to talk about this building if we had specific points, lines, angles, and shapes all labeled like you see in this next picture here? Okay, so the big thing we're going to do today is make sure that we have a common language to talk about geometry as we go through the year. Okay, we want to make sure we're on the same page with the definitions, okay, on the same page with what the different pieces that make up geometry mean. Okay, that's our big goal here today. So we're going to begin by going over the basics, points, lines, and planes. Now essentially everything we look at in geometry class this year is going to be made up of points, lines, and planes. Okay, so we can think of these as the building blocks for all geometry. Okay, what is a point? Well, we'll say it indicates a location. So for example, in my diagram, a point is just this dot here. Okay, it's pointing out a specific location on my screen, okay, or a specific location in your note guide. Okay, it has no size, so we're never going to worry about how big the point is or how small the point is. It's just the location. And the way you'll name it is just with a capital letter. We'll always give our points capital letters for names, so in this case, we'll just call this point D. Alright, building up from there, next thing we'll talk about are lines. And I say building because you can think of a line as just a collection of points all put together. We'll say a line is a path that extends in two opposite directions without end. So for the diagram, I have two examples of lines here for you. And we said without end, so with a line what we'll do, we can't actually draw an infinite line. We'll put arrows on to show this line is going to continue on and on forever up to the right, and then on and on forever down to the left. Okay, so in the real world, we actually don't run into any lines ever. We'll talk about what it is in a few minutes when we have a partial line, but in geometry, lines go on forever. Just like with a point, we're not worried about how thick that line is. It's just kind of the direction it points. And then for naming lines, there's two ways we can do it. We can use any 2 points on the line. So for example, for the first line I have on the left, it runs through points A and B, so I could call that line AB, okay, with a little line symbol with the arrows above it. Now for that, order does not matter, so I could also call it line BA. That would work just as well. Okay, or in some cases, when we're not worried about the specific points, we'll give the lines just lowercase, usually italicized letters like M. So this line on the right I could call line M, kind of disregarding all the points to it. Okay, so we have points, we have lines, and then planes are essentially built off of a bunch of lines just stacked together. We'll say a plane is a flat surface that extends without end. Okay, so here we kind of have a tilted rectangle to represent a plane for us here. All right, the floor you're standing on is a plane. The desk you're sitting on is another example of a plane. The ceiling is an example of a plane. Again, we're not worried about thickness. And then to name a plane, we can do it 2 ways. We can use at least 3 points that do not lie on the same line. So for example, this plane has points A, B, and F on them, not in a straight line, not collinear. So we could say this is plane ABF. And I could do those in any order. Okay, or we could name it with a capital letter that's attached to the plane. So as you can see, W here, there's no specific point it's attached to. So I could also call this here plane W. Alright, so that's our points, lines, and planes, definitions you need to know, stuff we'll be using all year long here. And last thing we'll talk about quick are the idea of collinear points and coplanar points and lines. Okay, collinear points will say are points that lie on the same line. That co prefix meaning with, okay, so with the line, on the same line. And then coplanar, the same idea. Coplanar will say are points and lines that lie on the same plane. Okay, again, with the plane. Okay, so collinear, same line, coplanar, same plane. All right, that's our first set of definitions. Next up in the note guide, there's problem 1. Okay, I'm going to run through that in a second here. What I'd recommend to do is take a minute, pause the video, see if you can answer those questions on your own, see if you understand those definitions, and then hit play, and I will run through the answers for you quick. You definitely want to try this on your own, not just watch the teacher do it. All right, so let's go ahead and go through problem 1. And again, hopefully you've already paused the video, worked through these on your own, and you're checking the answers, not just watching me do them. Okay, so in problem 1, we have a geometric figure which is supposed to represent a plane kind of tilted to the side, along with a line coming through the back of it and popping out the front. Part A asks, what are 2 other ways to name line LJ? Well, there's only one line on here, but if I ever had to find that line LJ, what I'd do is I'd find point L, I'd find point J, and then I'd just connect my dots. Okay, so I know I'm talking about the line in blue here. Now, other ways to name it, number 1, right off the bat, I don't even need the picture. I can just flip the order of the letters around. We can say instead of LJ, we could say JL. Okay, or since I have more points, I have the point K, I can mix that in here. We could say line LK. Okay, or line JK. Okay, or there's a bunch of other ways to do it. If you came up with other answers that still work, that's okay. Essentially take any 2 of the 3 points in any order. That's going to be a good way to name that line there. Now that's also showing you one of the tricky parts of this course is I might say line LJ, you might say line KJ, and we need to recognize we're both talking about the same line. All right, so that's naming lines. Part B asks, what are 2 ways to name plane DAB? All right, well again, there's only one plane here, but if I find the points D, A, and B, they're all on the plane I see here, so I know I'm talking about that plane. Okay, there's 4 total points on that plane. So for naming a plane, I need 3 of them, and the order doesn't matter. So I could say plane JBA would be a good way to do it. Okay, so any 3 of the 4 points in any order is going to work. Now the other thing I can do is notice there's a P here floating by itself, not attached to a point. What that means is we could also call this plane P. Okay, and those are 2 names for naming a plane, 3 points on the plane, or just a capital letter attached to that plane. Okay, again, there's a bunch of other ways to do it. We don't have to have the same one. We can still get the right answers. Okay, part C asks about collinear points. It says, what are the names of 3 collinear points? In other words, 3 points on the same line. It looks like here the only collinear points I have are going to be L, J, and K. I can tell that because they all lie on this line I have in red here. Okay, DJB doesn't quite look like it's in a straight line. Looks like there'd be a curve to that. So we can just say L, comma, J, comma, and K are collinear points because they're all on the same line for me. All right, last one then, D, what are the names of 4 coplanar points? In other words, 4 points on the same plane. Well, my plane P here has 1, 2, 3, 4 points on it. So those are my 4 coplanar points. We'll say D, comma, A, comma, J, comma, B would be the 4 coplanar points. The next thing we're going to do is look at the definitions for 2 figures that are parts of lines or partial lines. Those are going to be segments and rays. I'm going to say a segment is part of a line that consists of 2 endpoints and all the points between them. So in the diagram we have an example of a segment here. Okay, it's part of a line that doesn't extend forever. It's just the things between the endpoints. So if you want to think about how could you create a segment from a line, well, if I have a line that extends on and on forever in both directions, for a segment what I'll do is I'll pick 2 endpoints, 2 points for my segment to end at, and the segment's going to be made up of everything you see in blue here, okay, all the points between those endpoints. Okay, you can name a segment by its 2 endpoints, such as in this case we could call this segment AB. Okay, or BA, just like with a line, the order is not going to matter. Okay, and notice I have a segment symbol on top. There's not the arrows. That's how we'll differentiate if we're talking about a line or talking about a segment. Okay, we have a ray next. It's also part of a line. Okay, and this time that consists of one endpoint and all the points of the line on the other side of the endpoint. So a ray has an endpoint and then extends on and on forever in one direction. So again, if I want to create a ray from a infinite line, what I'll do is I'll pick an endpoint for it, and then I'll extend in one direction, all right, excluding everything before it. You can think of a ray as kind of like half of a whole line. Okay, you can name a ray by its endpoints and another point on the ray, such as in this case we'll say ray AB. Okay, notice we have the ray symbol on top with one arrow, arrows on one side. And we're always going to label the ray from left to right. Even though this ray extends from right to left, we'll always have that endpoint first and put that arrow pointing towards the right, whichever direction the ray is facing. Okay, so for this one, I could not say BA and make that arrow going backwards. We'll say that's not a good way to name that ray. And then one more thing we'll say about rays. Let's talk about opposite rays here quick. I'm going to say opposite rays are two rays that share the same endpoint and form a line. Okay, so in other words, if I have an endpoint, and I make a ray extending off of it, and I make a second ray with the same endpoint, and go in the complete opposite direction, forming the straight line here. Okay, so I have a green ray and a blue ray. Since they form a line when I put them together without any overlap, we'd call them opposite rays. Okay, same endpoint and share a line. All right, next up is problem 2. Same deal. Pause the video here, work through that, see if you understand these definitions, and then hit play. We'll go ahead and run through them together. Let's go ahead and go through problem 2, naming segments and rays. Our geometric figure this time is an infinite line with some different points on it. And part A says name the segments in the figure. What are the names of the segments in the figure? And I'm seeing 3 of them. First one I see is DE, everything between D and E. So we'll say capital D, capital E with a segment symbol on top, no arrows. Now again, I can name these segments in either order. So I could also say or ED. That would mean the same thing. You don't need to name them every way possible. You just need to name them all once. Either of those would work. Next segment I'm seeing is from E to F. So we'll just say segment EF. And then finally, if I take those 2 smaller segments and put them together, I get a different segment, D all the way to F. So we'll say DF. Next up, let's talk about the rays. What are the names of the rays in the figure? And I believe there's 4 of them. First one we can do is start at E and run through F on and on forever. We'd call that ray EF. Okay, with that arrow pointing from endpoint through the next point. We can also start at D and run through F on and on forever. So DF is a different ray. Now, they both head in the same direction. They both have a lot of overlap, but the difference is that endpoint. Okay, DF has a little bit more to it than the EF, so we'd say those are different rays. Now, one trick with this is there's another way I could name that ray. I can't switch the order of the points. What I could also do is I could say ray DE. Because whether it starts at D and runs through F on and on forever, or starts at D and runs through E on and on forever, it's going in the same direction, so it's the same ray. Okay, we can also look at ray ED. Again, we'll always start with the endpoint and name it left to right, even though this ray is running from right to left. So we'll say ED with the arrow on top of it. And one more color here. The last one would be FD. Okay, again, kind of overlaps ED, but it has a different endpoint to it. All right, so that's our rays. In part C, let's talk about opposite rays real quick. Okay, which of the rays in part B are opposite rays? Well, we said that opposite rays share an endpoint and form a line. So that would be rays EF. And then to form the rest of that line, we'll go ED. They both have the E, they both have the same endpoint, and when I put them together, they form a whole infinite straight line. And the last thing we're going to talk about today is the idea of a geometric postulate. I'm going to say a postulate is just a statement that is accepted as fact. Okay, so it's not something that we can prove is true, it's something we just have to accept. And in most cases, postulates are essentially common sense. When I give you these postulates, we're going to say, yeah, of course that's true. Okay, that's the way shapes work, points, lines, and planes work. Okay, the reason we'll name these out is so that we're all clear about kind of what the rules of the game here are and clear about kind of agreeing on how geometry works. Let's give you some examples of postulates. First one is through any 2 points, there's exactly one straight line. So for example, if I draw 2 points on the screen here, and I want to make a straight line, we'll try to make this as straight as I can. That's the best it's going to get here. There's only one way to do that. Okay, if I had a ruler, we could make it nicer, but we'll say there's one way to do that. Any other line that goes through these 2 points, if it's not the exact same line, it's going to have to be curved. Okay, that's where we're seeing there's only one way to draw a straight line through 2 points. Okay, so 2 points distinguish a line. Now that's why we do need 2 points to name a line instead of one. If I just have a single point, I can make multiple straight lines through it. But if I have 2 points, there's only one straight line possible. Okay, so that's an example of a postulate, kind of a common sense statement. Okay, postulate 2, if 2 distinct lines intersect, then they intersect in exactly 1 point. Okay, meaning that if I draw 2 lines together and I make them intersect or run into each other, their intersection is a single point. Okay, they come together at 1 point. There's 1 point in space that they share. Again, kind of a common sense statement. Next set of postulates deal with planes. The third one is if 2 distinct planes intersect, then they intersect in exactly 1 line. Okay, now I'm not going to try to draw this for you, but we'll describe what's happening here. If you look out ahead of you and look at the ceiling, which is a plane, and the wall in front of you, which is a plane, and take a look at where they meet up at, okay, well that edge that they share is a straight line. That's what this is saying, is where 2 planes come together, the shape they make is a straight line. Okay, that edge you see between your ceiling and the front wall in front of you is a straight line. All right, last one, through any 3 non-collinear points, there's exactly 1 plane. Okay, again, this one's hard to draw, but we'll describe. Just like through any 2 points, there's exactly 1 straight line. Through any 3 non-collinear points, okay, points not on the same line, there's exactly 1 plane. Okay, that's why we use 2 points to name a line, and we need 3 to name a plane. Okay, so you can distinguish exactly which that plane is. All right, let's go ahead and put those postulates to work here. Problem 3, it says each surface of the box represents part of a plane. So what I have for this geometric figure is a box essentially, and we can think of the sides of the box as a plane. The edges then would be lines, and each corner would be a point. Part A asks, what's the intersection of line AD and CD? Now we just said that when 2 lines intersect, they intersect at the point. So let's trace these out here. I've got AD in the upper left and CD on the top back. And as far as the point they intersect at, that's going to be this corner here. In other words, point D. D would be my answer for that one. Now I suppose with this one I can cheat. I can see that D is in both these lines' names. Okay, that's how I know that D is the answer for that one. Part B asks, what's the intersection of plane ADC and BFG? All right, well, ADC, let's find those points. We've got A, we've got D, we've got C. Okay, so those are all on the top of the box. So for that part, we're talking about the top of the box here. And plane BFG, let's see, B, F, and G are all on the right side of the box. So that plane is dealing with the right side. Okay, what's their intersection? We just said a minute ago that planes intersect at a line. Okay, so the line they share, the edge they share is everything between C and H here. So we could say segment CH or line CH, either one. But these two planes intersect along CH. All right, and our last question is going to be the opposite question. Okay, in B we gave you two planes. We asked what's the intersection. Here we're going to give you the intersection and ask what are the planes. So C says what are the names of the planes that intersect at line BF. Well, let's see here. Here's line BF. And what I want to do is I want to label the planes that come together that intersect along that line. Okay, well that would be the front of the box and the right side of the box again. So we have the front of the box, which I can pick any 3 points from to name. So we could say A, E, F. Okay, so any 3 points in any order to name a plane. All right, and the right side of the box, picking any of those 3 points, we could say B, C, G. All right, so those are the two planes that intersect at this line BF here. All right, that's it for lesson 1, points, lines, and planes. Simple stuff, but foundational. We're going to be building off this throughout the rest of the year. So it's really important that you have a good understanding of these definitions, of how they work, how to name them as well. Okay, so make sure you get through the homework, make sure you get through the practice, the Math Excel. Ask questions if you need to. We're here to help you out, and we'll see you folks next time.